Arduino and this whole open source hardware movement has created some incredible things. And tonight at the MHVLA Open Source Mad Science Fair, we had some great projects out here.
This project is called Heartbeat Dome. It was exhibited last summer at the Burning Man Festival outside of Black Rock City, Nevada. It's a piece that takes your heartbeat in from an oximeter sensor and translates it into light and into subwoofer sound.
I didn't really have time to get a full build prepared to bring out here, so I just made blinking lights. The canonical first Arduino project, and then I just tried to take it to the next level. Led to a lot of discovery about how the eye works, so that I figured out that brightness perception is not linear, and had to make some lookup tables, which led to some great calculations and just a lot of discovery of what happens in that circuit.
It's basically just a little LED, RGB LED, that has a little ping pong ball in it, and it's filed down to be diffused so it gets more even color. But I saw this little cool floaty thing that just kind of changed colors, and I was like, oh, I can do that. And so I showed up at an Arduino event, and by the time I left, I had the code working, and I had it fading in and out between two channels, and I tweaked it a little bit more and kind of got it to be smoother.
It's my first project with the Arduino. It's 148 LEDs that I soldered onto a board, and I brought it to use as a sign for Sophie's project. It comes with many libraries that you can utilize. It has games like Tetris and Pong, and right now I'm just using the MyFont library to direct people towards the project.
I'm Rebecca Strauss. I made a piece called Touched. It was my Master's of Fine Art thesis piece for my sculpture degree, and what it is it's a interactive kinetic sculpture that it basically consisted of about 50 individual fully opposable fingers that on approach of the viewer reach out and kind of do a kind of beckoning motion, and if you touch them, they recoil rather violently, then kind of cower for a little while. The idea that I was working with was this idea of hunger and touch aversion, and just trying to make people aware of how touch interaction affects us in our daily lives. The Arduino was a really great platform because I have no tech background at all, and it was something that's really open and accessible, so I used the Arduino to control everything. I used digital servo motors to control the motion, and I used pulley and cable system to move the fingers. The sensors are an infrared proximity sensor and a capacitance sensor. The proximity sensor senses the distance of the viewer from the piece and triggers the movement, and the capacitance sensor is attached to conductive thread, which is woven all through the surface of the piece, and it picks up the touch of the viewer. So when the viewer tactilely interacts with it and they touch it, the cap sensor picks it up and causes the piece to respond.
The Arduino that we just saw is a RPM detector. Its intent is eventually to have an LED display, and it will be an RPM indicator for my wood lathe. Right now, it's counting the revolutions of a magnet that passes by the Hall effect sensor. It counts the number of milliseconds between each pulse, and then when it reaches 20 pulses, does the math and displays the resultant RPM on the computer screen in this case. Once we get the LED on, it'll be a standalone module. I can just mount it on my lathe, mount a sensor point to my lathe on one of the drive shafts, and I have an RPM gauge for about $30.
I also wanted, what the main thing was is the MOSFET transistor tester, where I was interested in measuring the current through it and the voltage across it. And the motivation for doing that is I read a column for Circuit Seller magazine. And so what I did was the 3-column series on the physics behind it and how you would actually do something like this. And what the Arduino does is provides the logic. So you think of that as kind of the thing that makes it work. But the actual point of the article is all the analog electronics that fits on that circuit board.
My project is making ground effect lights for my longboard. And it's a thing where you put LEDs on the bottom of your board and it just looks pretty. I'd like to know how fast I'm going. So the board here, and I'm going to put a sensor on the inside of the wheel that will generate a pulse every time a magnet goes by. I'll then calculate the time between those pulses and use that to calculate my speed by doing mathematical magic in there. From that, I will feed speed into equations that will control the output of my LEDs. And from there, I'll be able to control the colors of the LEDs, and I'll modulate the color by speed. So while I'm on the board, instead of having a numerical readout or a dial or something crazy like that I won't be able to read in the dark, and I don't really care precisely how fast I'm going, so the color will tell me roughly how fast I'm going, and then I'll just be able to estimate. Also, it'll look really cool.
Okay, so what we have here are basically a bunch of parts to build the Arduino, as well as BeagleBone. What we have is Cedo. I have some logic analyzers in here. Basic project I'm working on right now is a first-person flying vehicle. What we're basically working on is an Arduino Android display, and the Android is flying inside my quadcopter, as well as a plane that I have ordered that hasn't been delivered yet, similar to what Sean is doing over there. We've been getting parts from Adafruit, we've been getting parts from SparkFun, getting parts from Polo, as well as DigiKey.
This is a Raspberry Pi, and it is a little tiny board that has HDMI, 2 USBs, and Ethernet, Wi-Fi, and this is the B model. There's actually an A model that's being sold now after the fact, which is a stripped down limited version. My intention with that is to actually try and stream audio with it for my DJ sets, and I also want to see if I can run my DJing software, Xwax, off of it. We'll see if that works.